let's draw a diagram for the object and set up Newton's second law here. So the first thing we're going to do is we're going to draw an aluminum cube that is in the water. Okay, it's attached to some sort of string or whatever, and here it is in the water. So I asked myself, what are the forces acting on this? Gravity down, buoyant up, and some sort of lift force that's pulling this object up or holding this object up. And then we're going to set up Newton's second law, which is just F equals ma. So we add all the forces together, being careful to add things in the same direction and subtract things in the opposite. So it's buoyant force plus lift force minus gravity equals ma. There you go. That's all you have to do for step 1. Step 2. Find the buoyant force using the weight of the fluid. Remember, the two ideas from that. So the two ideas that we talked about for earlier, we'll get to that. And you'll need to use the density equation to help you jump. I actually think I made this way simpler for you, so we'll just solve it. Find the buoyant force using the weight, so find the buoyant force. So we can't use this equation to find buoyant force. We do know the weight, so Fg is mg. So we can figure that out. Okay, we know the mass, so we know m, but we don't know these two things. So we need to find the buoyant force. I gave you a buoyant force equation. Buoyant force is equal to the mass of the displaced fluid. I didn't tell you that. I told you the mass of the cube. I told you the density of the cube. I told you the force on the cube. I told you the density of water. I did not tell you the mass of the fluid. So this equation is out. But I gave you another equation, and that's this one. Fg equals density of the fluid times, make sure I'm writing the right one down. I hate to lead you astray. Mass of the object over the density of the object times g. So, density of fluid, water, is 1,000. Mass of the object, 550 grams, so 0.55 kilograms. Density of the object, 2.7 times 10 to the third, that is 2,700. G is 9.8. So, plug them in. 1,000 times 0.55 divided by 2,700 times 9.8 gives me a buoyant force of 1.996. We'll just round it to 2.0. And the last step is to use Newton's third law to find the amount of force needed to lift the mass. So now I'm going to go back to this equation. Now I know what the buoyant force is. It's 2.0. So now I just need to plug in and solve for the lift force. So buoyant force is 2.0 plus lift minus gravity, force of gravity, so that's 0.55 times 9.8. It is 5.4 equals ma. The mass is 0.55. What's the acceleration of this object? If it's just suspended in the water? 0. Yep, it's 0. I'll give you a hint. It's always 0 unless I tell you otherwise. So if I say so, then there's an acceleration. Otherwise, it's 0. Even if it's going up at a constant speed, that's 0. If it's staying still, that's 0. So it's 0 unless I say otherwise. Okay? Add the 5.4 to the other side. Subtract the 2, and you get the lift force equals 3.4. So, if the object weighs 5.4 newtons when it's out of the water, when it's in the water, it weighs 3.4. And that's because the buoyant force is acting on it.